Let me move some interesting topic, that is what you call the cam dynamics. So cam dynamics means when there is a rotational movement takes place, as we said, it is similar to that cam and follower mechanism, which is similar to the movement of piston and crank. Okay, so if you're going to take this cam shaft diagram and along with this cam and follower mechanism, both has been similar kind of motion wherever the follower will make the movement in linear direction and the cam has make a movement in rotational direction. Okay, so the valve opening and closing, that inlet valve and exhaust valve in the engine diagram. Okay, if you're going to take about that engine assembly, these two kind of valve which has been adjusted with the help of the cam and follower mechanism. Okay, so it has been calculated by using some technical parameters, that is what you call that follower displacement, cam rotational speed, along with that velocity, along with that acceleration, and along the moment of inertia, that is what you call the jerk. Okay, and this cam dynamics which has been changed with respect to the moment of rotation. Here the follower having this following kind of motions. The first one, it is an uniform motion, and the second one, it is the simple harmonic motion, and the third one, it is the uniform acceleration and retardation, and the fourth one, it is the cycloidal motion, and fifth one, it is the general polynomial motion. Okay, so here the uniform acceleration and retardation we also use to call it is a parabolic motion, and several different standard functions can be used to describe the motions of the followers and use the basis of constructing the displacement diagram. So with the help of this cam and follower displacement diagram, we are going to calculate about the velocity, and also we are going to calculate about the displacement of the follower with respect to the cam angle movement. This cam angle and the following motion, it has been varied with respect to the engine speed, and because of the constant loading and because of the constant suction and the stroke, and as well as the different kind of strokes which has been acted, this cam movement has been analyzed with the help of the movement of the follower and as well as with the help of the stroke. So several different standard functions are there, can be used to describe the motions and the basis of displacement diagram, and these displacement profiles is used to determine what kind of shape that the can have it, and also it has been used in kinematic and as well as the dynamic analysis of the concerned mechanism. Okay, so here I just going to take about one interesting topic, that is what you call that uniform motion, or otherwise it is the simplest follower motion which we are going to say. So this motion has been characterized, either it may be a straight line concept or either it may be a rotational concept. Okay, so this motion has been analyzed in with respect to the displacement of cam and also with respect to the displacement of follower. So the distance taken to travel by the follower has been taken into the consideration before we are going to draw this cam and follower diagram. And with respect to the shape, these parameters which has been keep on varying on the cam and follower motion. So that is what it going to analyze that exact movement of the cam diagram and exact movement of the follower diagram. Okay, so this diagram is purely represents the straight line displacement function and as well as their velocity. Okay, the another motion which is what we call that simple harmonic motion. This simple harmonic motion is keep on varying like that simple. The meaning of simple harmonic means it is a timing oscillation, which means this oscillation which keeps on exerting there is certain kind of motion with respect to the rotating disc, and as well as it is projected in the straight line and it delivers the constant velocity, displacement, and along with that we are going to calculate the acceleration. So with this, I just go and wind up, and thank you so much for taking part.